Hello everyone. Today I am back with another video, that is second part of reversible equilibrium. In the last part we have seen about reversible reactions, what is dynamic equilibrium and factors affecting equilibrium. Based on equilibrium we have two main processes, that is make Haber's process and contact process. So Haber's process is an industrial process of making ammonia which is performed in an open system. This is the reaction nitrogen and hydrogen giving us ammonia, where the forward reaction is exothermic and the backward reaction or the reverse reaction is endothermic. Now, as we are performing an equilibrium reaction, there are some reaction conditions which we have to maintain. Okay, so the temperature used here is around 400 to 450 degrees Celsius. Pressure is 200 atmospheric pressure, or we can say 20,000 kilopascals. Catalyst used is finely divided iron, as we have to increase the rate of reaction. And from where do we get nitrogen and hydrogen? So we get nitrogen from air and hydrogen from hydrocarbons or by electrolysis of water. So this is the process, how the Haber's process is done, how ammonia is being produced. So nitrogen and hydrogen are pushed here in this chamber where they are mixed together so that all the impurities or the traces will be removed. Next they are sent further to the compressor where the pressure is being maintained. Further, nitrogen and hydrogen mixture goes to the bed of the catalyst where the catalyst is present. Okay, here nitrogen and hydrogen combine, react together, and they form ammonia. This mixture of nitrogen, hydrogen, and ammonia comes down where where ammonia is being liquefied, and then it is being stored into the tanks. The unreacted nitrogen and hydrogen are sent back to the bed of the catalyst where they will react again. So they are being recycled, nothing goes waste here. So as I was talking about the source of nitrogen and hydrogen, here you can see the air is made up of around 78 to 80% nitrogen and remaining part is oxygen. Okay, and 1% is other gases. So how we get nitrogen? Hydrogen is being reacted with air. So hydrogen reacts with all of the oxygen to form water, and the remaining is nitrogen which is being taken for production of ammonia. Where how do we get hydrogen? So hydrocarbons, that is methane is an example of hydrocarbon, is reacted with water which give in presence of catalyst, which gives us carbon dioxide and hydrogen. This hydrogen is then used as a source for production of ammonia. It can The second method is by cracking of hydrocarbons. So if we are having long chain hydrocarbons, so that can be cracked means breaking down into smaller compounds. Okay, so here we can see we have converted ethane to ethene, and as ethene is having double bonds across a carbon, so the hydrogen is being removed. So in this way also we can get hydrogen. Now as we have seen that the forward reaction is exothermic in nature, so there is no need for increasing the temperature. But here you can see there is a graph drawn of temperature against the yield. So as you can see we have the highest amount of yield when we operate the reaction at around 350 degrees Celsius. Okay, but what happens at 350 degrees Celsius? The reaction goes very slowly and it will take a lot of time for the production of ammonia in the at the industrial level. That is not feasible. Okay, as if we are using higher temperature, so as the forward reaction is endothermic, we do not need high temperatures. If we you increase the temperature, it will start favoring the reverse reaction, that is endothermic, and instead of ammonia, production of ammonia itself will break down to make nitrogen and hydrogen again. So we use an optimum temperature of 450 degrees Celsius at which the reaction is being triggered, and also catalyst is added to increase the rate of reaction. Contact. So here we have contact process. Okay, contact process is similar like ammonia, where here we are producing concentrated sulfuric acid. The raw materials required for sulfuric acid production is sulfur, air, and water. Now the source of sulfur is obtained from fossil fuels by desulfuration. Now, the reaction conditions required for production of sulfuric acid is somewhat similar to ammonia. So the temperature remains 450 degrees Celsius. Next, the pressure is 2 atmospheric pressure, and catalyst used is vanadium oxide here. Okay. Now, how the process goes? So, sulfur is reacted with excess air. From air, sulfur reacts with oxygen. It combines with oxygen to form sulfur dioxide. This sulfur dioxide is further reacted with air to form sulfur trioxide, which is a reversible reaction. Okay. Now, this sulfur trioxide can be directly added to water to form concentrated sulfuric acid. But this step is done very carefully as it is a highly exothermic reaction, okay, and which leads to very thick fumes of concentrated sulfuric acid, because of which this step is being skipped. Instead, this sulfur trioxide has been mixed with concentrated sulfuric acid to form oleum, which is H2S2O7. This oleum H2S2O7 is then in the next step added to water to form concentrated sulfuric acid. Thank you.